All right, so we are on September 17th. Today we're going to start talking about solids, liquids, gases, and plasma. The most under-discussed state of matter up until this point in your educational career. Plasma is one that we just don't discuss a lot because we stay focused on those top three: solids, liquids, and gases. Sixth grade, we like to pull in that plasma discussion. So that's what we're going to be talking about today. You are going to be taking notes. I put that in the instructions in the Google Classroom piece. So you have to use your journals today, guys. What we're going to be doing on the board is a huge test question later on. Can't get any more plain than that. So you will need the information here so that you can study it later on. All right? So if we were learning in school, I would walk around and I've got a spray bottle and I would be spraying the tops of your desk. And then I would have you take a book and fan the tops of your desk. And then we would talk about what happens to the water. After you fan for 4 or 5 minutes, where does the water go? Some people would say, well, it disappears, or I don't know, it goes away. But really what happens is that water evaporates. So it goes from a liquid state and it evaporates and goes into a gaseous state, turns from a liquid to a gas. And so we're going to talk a little bit about really and truly what does that mean today. So the first thing we want to talk about is a solid. And I want you to draw a square in your journal, kind of a medium-sized square. Maybe take up 1/4 of the page. And so I'm going to do the same up here. So I'm going to draw a square and I'm going to write solid. Now, one of the things that we want to really talk about a solid is, what the heck are you talking about? I had a student that gave me this one year, but this is a solid. I can't bend it. I don't have the strength. It could probably be broken with quite a bit of effort, but it is definitely a solid. What I want you to think about, that a lot of times you've never realized, that it is solid and I can't tell that anything's moving. However, the particles that are making up this piece of wood are actually moving. They're reverberating against each other. Even though we can't see it, our walls, our doors, our floors, our computers are actually moving. We can't see it with what we call the naked eye, but if we had a powerful enough microscope, we could see all of those particles just kind of straining against each other. So what we're going to do now is we're going to fill in our solid box. And I like to use circles. And we're going to put them tightly together. With very little space in between. So they're kind of going to be touching each other. They are tightly packed. So we want to keep that in mind too, that the particles are tightly packed. And that's something I'm going to write underneath it. I'm going to say particles are tightly packed. Now, what I want you to think about is, if you stood up and you stood as straight as you can you still move? Yeah, you can move, but it's really stiff feeling. You want to be as tight as you can make yourself. And so that's what's going on in our solids. There's still movement, but it's such a looseness, a tightness to it, that it's not very loose at all. So let me ask you this. Do solids have a definite shape? Does this have a definite shape? If I take out the little pointed pencil, does this rectangle have a definite shape? Yes. All solids have a definite shape. My door of the classroom has a definite shape. That means that I can't manipulate it and turn it into something else. So underneath this, I would write definite. Has definite shape. And I'm going to abbreviate definite. Now, we did a little bit with our last section about volume. Could I find the volume of a solid? And what was that equation that we did for a solid? We did length times width times height. So could I measure the length? Could I measure the width? Could I measure the height? I could. If I can do those things, then it does have a definite volume. So I'm going to say has now. So that is solid out of the way. Now we're going to do the same thing with a liquid. I'm just going to draw that little squiggly line there just to kind of have some definition between one thing to another. Now, with my liquid particles, I want you to think about when you are drinking water out of a glass, or you are running water in your sink, or you're pouring a drink in a cup. Does your liquid particles, are they as tightly packed as your solids? No, there's movement to them. And I like to call it the loosey-goosies. Hey, what's happening? There used to be a cartoon. It had like this big, it's Finding Nemo. Has like the big tortoise on it, and he's got like the, yeah, what's going on kind of mentality. To me, that's what liquid particles are like. They got that looseness to it. So when I draw the particles in a liquid, would I make them as tight as I would I make them as tight as the solid? No, there's got to be space so those particles can move. So let's take a look at that. So we're going to give a little space in between them. So that they can move. So I'm going to draw some arrows. This shows that how they might be pinging off of each other. So there has to be space for them to do that. So it's kind of like, yeah, I'm going to move. Okay? So you have to ask yourself those same three questions that we did with finding a solid. Our first statement is, how are the particles packed? In a solid, we said our particles were tightly packed. Well, now they're not tightly packed. We can see from one to the other how they look different, correct? So now we're going to say that our particles are loosely packed. Now, we have to ask ourselves, does liquids have definite volume? Let's think about what we learned about liquids last week. If I take that 12-ounce can of pop and I pour it into a glass, is it still the same? Yeah, it is. So I'm going to say that it has a definite volume. How about a definite shape? It takes on the shape of the container. So it does not have a definite shape. Does not. Now, so we've got solids, some movement, but we can't move freely. Then we've got liquids that are kind of, yeah, what's happening? Now we got to talk about gas, okay? So I'm going to kind of make this go down a little bit, because now we are going to be discussing a gas. Now, if we thought a liquid was loosey-goosey, a gas is absolutely everything. I say that the particles that make up a gas is like you drinking 12 cans of Mountain Dew. It's kind of like, that's what the particles of gas remind me of. They are pinging off of each other so rapidly, and they're just everywhere. They have lots and lots of room because they're moving at such a fast rate. So to draw gas particles, we've got to give totally tons amount of space. And it's just kind of like pinging, pinging, pinging. And they're just bouncing every which way. So when I'm thinking about those particles, they are not tightly packed. They are not loosely packed. I would have to say that the particles are what? What could we say that would be different than loosely packed? We could say that, I'm trying to find a word that makes sense to you. So I'm going to say that my particles are let's say widely packed apart. Let's do it that way. Widely spaced apart. Now we have to decide what is a gas, okay? To be able to decide, does it have a definite shape and a definite volume? When we're talking about a gas, what does that mean? Well, we can't see the air that we breathe. However, it's a gas. We cannot see everything that's around us, but that doesn't mean that, well, let's back up. Let's think about this. When I think about gases, I try to think about as you breathe things in and out. So, and that's how I want you to think about it, because the oxygen is a gas. If we take a balloon and we blow up the balloon, the oxygen from our body makes the balloon get large, right? Now, but once I let it go, the oxygen disperses. So because it takes up whatever space that you put it in, it really does not have a particular shape, because it's like a chameleon. It can take on the shape of anything that you put it in. Like chameleons can change colors depending on what you're next to. So because a gas can take on the shape of whatever you put it, it has no definite shape. Now, the same thing would be, does it have a definite volume? It does not have a definite volume for that same reason, because it will take on the volume, and it's not a measurable volume. We can't do length times width times height to decide. We cannot submerge it in water, all of our other techniques to figure out a volume. So it does not, it has no definite volume. So our solid is tight, it's moving, but we can't really see it. Our liquid's like, what's up, dude? What's happening? Right? Our gases are like, the particles are just everywhere. Takes us to plasma. Plasma shares a lot of the same similarities with a gas, with the exception of one. So we are going to draw our plasma square identical to our gas square, okay? Identical. So we're going to say plasma, and we're going to say our particles are very loosely packed. You've had way too many Mountain Dews at Mama's house. She jacked you up on Mountain Dew, and now she's sending you home to your parents. Now, I said that it was exactly like gas with the exception of one quality. So, we know that our particles are spread apart, and we said widely spread apart. Sorry, my handwriting is getting worse as we go along. I said that it has no definite shape. And we said it had no definite volume. So, what's the difference, Miss Kim? What's going on here with plasma? Plasma is all around us. It is part of our environment. Plasma is most naturally found in electricity. It's found in lightning strikes. So it has an electrical charge to it, okay? So when we think about nature, that's where plasma is from. Now, can we reproduce plasma? Which means, can we produce an electrical charge? Yes. When we think about plasma, plasma is most used in neon signs. The colors that run through those tubes are full of plasma charges. So when we think about plasma, it's identical to a gas molecule-wise, with the exception of the electrical charge. So we're going to say plasma has an electrical charge. All right, guys. That's throwing my lid. That's the lesson for today. So, a lot of information going on here, and That's what I needed you to listen to. So tomorrow's lesson is going to be without me. You're going to be doing some reading, going to be doing a brain pop, and then you will be moving on into some scaffolded questions. So that's where we are. Bye, guys.